Hello, Laura Lewis. Welcome to the class on energy. Let's get this started. Move this out of the way. Okay, so in this class, we're looking at going over some energy-related exam questions. So this is appropriate for all exam boards. It's just generally about energy, so anyone can watch this. So what I'll do is I would follow along with me. So I'm going to write on the screen. Okay, let's get my pen working. Okay, so my pen is working. So let's have a look. So this is a weightlifter picks up a barbell. Okay, so which type of energy is stored in the barbell when it is held above the weightlifter's head? So what type of energy? So we've got a choice of chemical potential, elastic potential, gravitational potential, or kinetic. Okay, so let's just think about what each of these things mean before we attempt to answer this. The chemical potential, as its name suggests, is stored in chemicals. Things like batteries or fuel, if you're burning it, that would be chemical potential. So not a battery, you're not burning anything, unlikely to be chemical. Elastic potential, again, it's got a nice name to it. So elastic is if something is stretchy. There isn't anything stretchy going on here, so like an elastic band or like a bow and arrow would be an elastic potential, so nothing really like that's happening here. Right, gravitational potential is to do with basically what the weightlifter is doing is holding things up against gravity. So when you lift something up, okay, you increase its gravitational potential. So that means if you dropped it, it would fall to the ground, wouldn't it? Okay, so you're actually working against the Earth's gravity to pull it up. So if you lift anything up, you're increasing its gravitational potential. And the higher the object is, the greater the gravitational potential. So that is the answer, but we're just going to look at what this means. Kinetic. So kinetic means moving. Okay, if anything is moving, it's got kinetic energy. So this person's not moving, that's not moving, so it's not that. So sometimes if you don't know the question, you can look at elimination. But for this one, we know it is gravitational potential. If it's being held above someone's head, so I want my pen on, it is gravitational potential. So that you tick that box. Okay. So next bit, oops, just go to this bit going on the page. The weightlifter drops the barbell. The barbell store of which type of energy increases as the barbell falls. So we just talked about that. Okay, so not chemical, nothing to do with that. Nothing stretchy going on. Gravitational potential is not that. It's falling, it's getting faster, and it's moving as it falls. So it's kinetic. Okay, so let's get the pen on. Kinetic. Okay, that's the correct answer. So these are only 1 mark each, so they're quite straightforward. They're just tick box. Okay, so a little bit more involved. We're going to get here. So let's zoom in a little bit. Okay, so it says use the data in table 1. This is table 1, so it's title, to draw a line between each calculation and the energy change it is calculating. Draw 2 lines only. So yeah, don't draw more than 2. Always look at the highlighted words because you won't get any more marks. If you draw 3 lines, you don't get any marks at all. They'll just put no marks. Okay, so let's look at table 1 is telling us mass of barbell, 50 kilograms, gravitational field strength, 9.8 meters per second squared, height the barbell dropped 2 meters, and maximum speed the barbell dropped 6.2 meters per second. So calculation, 50 times 9.8 times 2. Okay, so it's asking us what that is, chemical, elastic, gravitational, or kinetic. So as we discussed before, we only had gravitational kinetic, so it's one of those, isn't it? So look at the previous question, give you a bit of a clue. Okay, it's going to be one of those. So what this is, let's get my pen out so we can draw on it. Yeah, okay. A different colour. Okay, let's get this. So this is the mass. Okay, I'm going to write a little bit over. We're going to look at what this is telling us. So mass times gravity. So I'll write as small g, is the reason why I'm doing that, times the height. Okay, mass times, so m, so mass times gravitational times height is how you calculate gravitational potential energy, or GPE, gravitational potential energy. Okay, if it's got height in it, it must be to do with the gravity. Okay, so 1 line, down to here. Okay, this one, a half, so it's just a number. So a number, we'll just write in half, that's just a number though, times mass. Right, we've got a different thing here, 6.2 is a speed, so or velocity, so v times v again. Okay, the shorter way of writing that would be sorry. If you make a mistake, just cross it out like that, even in a real exam paper. Make a mistake, don't bother rubbing it out, just cross it through. Okay, half times m times v times itself, v squared. Suddenly, oh, there we go. Oh, it's kinetic energy. Kinetic energy, or KE for short. Okay, kinetic energy. Okay, so we have to know these and be aware of these equations. As you can see, that they can ask in different formats. They can ask you to recognise what they're talking about too. So let's just change this. Okay, so it says the weightlifter's internal store of energy decreased when he lifted the bar. The bar's internal store of energy increased by a smaller amount. Explain why. Okay, that's interesting. Okay, because we say the internal energy or something, so it's sort of the chemical energy that the person's running on, like the fuel. Okay, so with efficiency, this is not obvious. Okay, what this is asking us. Let's think what it's asking us. So when energy is transferred, so when energy is transferred from one store to another, is transferred, okay, from one form to another, it is never 100% efficient. One form to another, it is never 100% efficient. Okay, efficient. So some energy is always lost to surroundings. So some energy is always lost to surroundings. Always, it always is. We don't want it to, but that's just the way that nature works. It's always lost to surroundings. Okay, it's usually lost in terms of heat and things like that. Sorry, surroundings. Okay, some energy is always lost to surroundings. Okay. So yeah, usually in the form of heat. So when the person lifted the barbell, they didn't all just go into putting gravitational potential energy into the barbell to lift it up. Some of it was lost as heat because the person heats up. Okay, let's have a look at the next question. Okay, right, so this is a recorded video, so yeah, if you missed stuff out, you can always go back. It seems like that might be going a bit fast, but if you want to go back. Okay, a bar chart, a little bit of little maths in here. So electricity in the UK is produced from a number of different energy resources. So figure 1 shows the proportion of each energy resource used. The labels have been removed from the pie chart. Okay, so let's complete the table. Okay, so it says that, I think we can kind of look at this, kind of be a little bit of working out here. So renewable fuels, 25%, segment label A. Okay, so percentage, it's out of 100. Okay, so people go, oh, I don't know, but percentage means out of 100. Okay, so A, and it's a quarter, 25 out of 100 is a quarter, so it's A. Okay, so we know that. So let's look at the smallest one. So oil, okay, 1, so it must be D. Okay, D. Okay, and then we've got a few other ones. So we've got coal, natural gas, and nuclear power. So let's look at the bigger one, natural gas. So that was over 25, so that's B. Got my pen. Okay. Coal was very close to being next to A, so it is C. Okay, and what is left was E for nuclear power. E was a little bit less than a quarter. Okay. Okay, so this is a 6-mark question, so it's always a bit more involved. Let's just zoom in a little bit here. It's always requires a little bit more thought, these questions, don't they? Okay, so it's over the next 10 years, many of the UK's nuclear power stations are expected to close. Okay, suggest how this may affect this. It could change all the time, especially this year. We were just in the year 2020. Yeah, this could be different. Okay, by the time we take another exam. So, but anyway, the form of the question still remains. So, over the next 10 years, many of the UK's nuclear power stations are expected to close. Suggest how this may affect the future balance of sources of energy used for electricity production in the UK. There's a balance of energy sources used in the UK. So you've got a few things to think about here. So let's have some key points. Let's zoom out and have some key points on this. Okay, so I haven't got my pen tool on. So if the nuclear power station is closed, we'll have to use other resources. So fossil fuel use would increase. Would increase. Okay. So fossil fuels would increase. Obviously, nuclear would decrease. Okay. So think about other things that could change. So renewable energy. Such as wind, solar, and hydroelectric would increase. Okay, to compensate for energy. Okay, so some problems with obviously that with nuclear. Okay, if they're closing, so balance use of electricity production in the UK, and some advantages. So if fossil fuels, it's what they say, fossil fuel use increases. So additional or more, okay, I've got additional. Carbon dioxide would be introduced to the atmosphere. I'll zoom out. Not meant to zoom that out. The atmosphere, enhancing global warming and climate change. That means making it worse. Also, that the UK doesn't have a source of its own fossil fuels. Apart from coal, most of our fuel is actually imported. So most fossil fuels are imported. So there's a bit of a geography question there. So you could think about, would that affect sort of trade and things like that? So for example, oil was piped in. Okay, some oil comes to the North Sea. Okay, so the best thing to do, okay, this is look at the actual mark scheme. This, so we've got a few things. Okay, always do that. Okay, always look at the mark scheme. So let's have a look. Same or greater energy required, or efficiency savings mean potential less energy required. Okay, so yeah, there could be a forecast to say that we might need less energy. I mean, it's unlikely, but so fossil fuels plentiful in supply. Yeah, but they're imported, like we said. Fossil fuels contribute to global warming. Yeah. Renewable energy is expensive to set up. So let's just talk about that a little bit more. Okay, so if we've got most of these points, okay, ready. Hot water, hydro, wind, biomass. And we've got, so let's always look at what you missed out. Sometimes it's not immediately obvious, but being used to these. Okay, so another point. Okay, was about the biomass. So biomass could be used. And I want to put in a word actually. So quite a lot of the UK actually does use biomass actually. Now it's a recent change as well. I'm going to sort of move down here a little bit. There's actually another point. Okay. Okay, about being expensive to set up. So about the infrastructure. So in this country, we mainly use coal, oil, and gas fired traditionally, but we are moving over to nuclear, moving over to a little bit, as I say, even though they were closing at one point, possibly 2020 will be a turnaround. Okay, but another thing is about nuclear and renewable energies, because they're not traditional sources of energy. So nuclear and renewable technologies are expensive to set up. See, and if it's debatable whether that's a good investment, are expensive to set up. Okay, so could be a good investment. Okay, could be a good investment. Okay, so that's sort of looking at one 6-mark question. I'm going to go for another one, so I'm going to go back to here for the minute. Okay, so let's log into here. Talking about energy. Not too bit longer than I thought. Okay, I've already got a microphone on, that's okay. Right, let's get rid of this. Right, we're going to go to our third slide where I've set up a question. Okay, so we're going to look at this. Explain the advantages. This is a very, very classic kind of 6-mark question where you get advantage and disadvantage. So explain the advantage and disadvantage of these two forms of power generation currently used in the case. So we're going to be up to date for 2020. So I put this in yet because this is a bit more up to date. I mean, exam questions are exam questions, and whatever it tells you, just answer it, okay? Because obviously these things change month by month, okay? So there's just been announced in the UK that we are going to use these two types of power, okay? And they are the main forms, apart from oil at the moment. So let's have a look at this. This is very up to date of today of when I'm recording. I looked at these things. Yeah, it changes all the time. So even if it's geography, you know that every year, every month it changes as plans. Okay, disadvantages and advantages. So when you look at a question like this, always draw yourself like a little table. So wind. I'm going to do advantage and disadvantage. Okay, advantage and disadvantage. I'm going to zoom myself out so I have a bit more room. Okay. Disadvantage. Okay. Advantage for wind. So it does not produce carbon dioxide. Not produce carbon dioxide. CO2, we're going to go for short. Advantage. Okay, so another one would be that actually the UK is quite windy. UK is actually in the coasts, plentiful wind supply. Very windy on the coast. If you've ever been to the sea, you'll know about that. Disadvantage? What disadvantages? Okay, so again, like we said before, it could be expensive to set up, but it could be a good investment. So expensive to set up. Expensive to set up. Disadvantages? Not entirely reliable. So if it's not windy, obviously there's ways you can overcome that by storing energy in batteries, which we're doing now. Today's technology. Okay, so no power when windy. When windy. When, well, not windy, sorry. When not windy. But that depends on where you put these things, okay? So yeah, some places will have a lot of wind and things. Okay, so we're going to talk about nuclear. So it's only 6 marks. So we've got 1, 2, 3, 4 marks already. Okay, nuclear. Again, same thing. Advantages, disadvantages. It's good to do this because it helps you think, doesn't it? And rather than writing continuous prose, you kind of all go blah, 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 blah. You forget lots of things. And if you do it like this, systematically, you will remember. And also, if you sort of do one, you think of the other one, don't you? Ooh, okay. Example, so we can say it does not produce CO2. So this does not produce CO2 either. The only thing that comes out of the cooling towers is steam. Okay, so like see things like Simpsons and things, or like cooling towers, it's only steam. It's not CO2. So this is similar. So it does not produce CO2, carbon dioxide. Remember, CO2 contributes to climate change and global warming. Advantages: does not produce. Oh, another one. Oh, another one. Okay, so renewable, so it will never run out. See, exactly. So when you do it like this, you remember extra things. Okay, so it does not run out. Okay, so nuclear, not entirely renewable, but it will last at least thousands of years. Okay, so I wouldn't say it's entirely renewable. So it will last for thousands of years. So coal and oil and gas are going to run out in the next few hundred or less. This will last for thousands, nuclear at least. Thousands of years. Okay, disadvantages. Okay, again, very expensive to set up, even more so than wind. Okay, a lot of setup. Obviously, the one we all know about, nuclear waste difficult to dispose of, because nuclear reactors produce nuclear waste. Difficult to dispose of. Difficult to dispose of. Okay, it's an unlikely one, but obviously everyone knows about it. Nuclear disasters possible. Actually, a very small percentage of any power plants ever undergo nuclear disasters. One of them, Chernobyl, was human error. It was humans doing something they shouldn't have been with a reactor. It's like an experiment. That will never happen again because people will not do that, and also that type of reactor isn't built anymore. People know that that's a dangerous type of reactor and they won't build it anymore. Fukushima in Japan was an earthquake. It was a natural disaster. Anyway, so these are actually that's a very small percentage. I'll put that in there, but that's very unlikely to happen. And actually, coal and oil and gas, even burning them to produce the carbon dioxide, will actually impact the health and lives of more people than nuclear power stations ever will. That's a good thing to look up on the internet and YouTube. Lots of videos about that. Okay, so this is a good way of looking at how to answer the 6-mark question and planning it out. Okay, so thank you for listening, and hope to see you in another video, and that's all for today. Goodbye.